In this video, I'm going to show you how to do some tests with experimental data to determine if a reaction is zero order, first order, or second order. This is an important skill that you'll need while we talk about integrated rate laws in general chemistry too. So let's pretend that these are our data. Let me just share my screen here. All right, here are the data. So we've got this reaction taking place, and we've collected time and concentration. And we want to know what's the order of the reaction and what's the value of the rate constant. So when you do these kinds of problems, I advise using Microsoft Excel. You can do it by hand, but it's not going to give you a very accurate graph. So the first thing you want to do is you want to select your time data. Control C, or you can go to Edit, Copy, and then go into, well, actually I'll just copy it all at once. So let's highlight it all, Control C, and now let's do share my Excel screen. Paste. Now the problem here in Excel is that what you want to be on the y-axis, excuse me, on the x-axis needs to go on the left. Okay, so you need to actually select this information, cut it, time needs to go here, and concentration needs to go here. Okay, so let's do the tests. Now if it's a zero order, then that means we're plotting concentration versus time. Okay, straight up, concentration versus time. If it's first order, we're doing natural log of concentration versus time. And if it's second order, we're doing 1 over concentration versus time. And whichever gives us a linear graph is our winner. Okay, that's how we choose the order of the reaction. And again, this is something that you need to know for tests, for quizzes, etc. So just make sure you know that somewhere. All right, let's do our zero order test. So we don't have to do anything here. It's already time versus concentration, so we just select it. And then we go to Insert, and then we select Chart with smooth lines. Now if this is something we're turning in, we would call it zero order test. And then we would go to Insert, go to Design, Add Chart Element, Axis Titles. All right, so what is this that we're plotting down here? Ask yourself that. All right, this is time, and it is in seconds. And then add chart element, axis titles, primary vertical. What is this? This is concentration, and it's in moles per liter. Okay, so there's that. Make it bigger. And now we need to know how good of a linear line this is. So I just right-click and click Add Trendline, Linear, and then Display Equation in R squared. Okay, close out of that. So that's a pretty good R squared, right? That's actually a really good R squared, 0.9429. But the closer our R squared is to 1, the better fit. All right, so just so you know, that's not perfect. Let's see if first order or second order is better. So let's do first order test. So now I want to highlight my time. And again, this is Control C to copy. You could also just click this button right here that says copy. Then go here, Control V, or just click paste. Now for first order test, we want to do natural log of concentration. So we're going to enter a formula into our toolbar up here. We say equals, then we type in ln, and then open parentheses, then we select our first concentration, then we say close parentheses, and then we hit enter, and it takes the natural log. Now notice, if I hover my mouse right over that corner, it turns into a little plus sign. Ah, crud, I put that in the wrong place. We need it right here. Equals ln, this one. Right, because this is natural log concentration. So now, hover my little mouse over it, make the plus sign, and drag it straight down, and it applies that formula to everybody. So it's taking the natural log of all these numbers. Highlight, insert, smooth line, move it down here where I can look at it nice. Again, if this were something I was turning in, I would say first order test, and then I would go to design, add chart element, axis title. What am I plotting here now? Again, look back up at our data. Right? This is still time, nothing's changed there, and it's in seconds. And then add chart element, axis titles, vertical. What am I plotting here? Oops. Natural log of concentration. Okay, and so when we do that, we have a trend line we need to add. So right click, add trend line, and then go to display equation, display R squared. All right, R squared here is 0.9852. Well, that's even better, right? Because our original was 0.94, this one's 0.98. This means that this is a better fit. But who knows, maybe our third test could be even better. So let's do second order test. Time is still in seconds. Copy, paste. Now to enter this formula, you type equals, open parentheses, 1 over, and now you select, oh, I'm doing it in the wrong spot. This is 1 over concentration. Now, equals 1 over, select your cell, close parentheses, enter. Again, hover your mouse right over, make the little plus sign, drag it down, and it's applied that formula to all these, so I don't have to type it in a bunch of times. Now we go insert, smooth lines, and let's move it somewhere where I can see it. Nice and neat. Make it larger. Second order test. And now design, add chart element, axis titles horizontal. This is still time, seconds. Add chart element, vertical. This is now 1 over concentration. All right, so if it's moles per liter, that'd be liters per mole. And now, just so you know, I've been right-clicking, right? I've right-clicked to get that. You could also add your trend line by going to Design, Add Chart Element, and then select Trend Line, and then choose Linear. And then click this little plus sign right here. Notice trend line selected there. So that's another way I could do it. But when I go to trend line, go to more trend line options. And then, oops, that's just telling you the size of the line. Never mind. So when I do my right click, format trend line, I want my equation and my R squared. All right, 0.999 versus 0.985 versus, what was that value? 0.9429. So the winner is the one with the R squared closest to 1, so it's 0.9995. So to answer my question here, what is the order of the reaction? New share. What is the order of this reaction? It would be second order. And the rate constant. How do I get the rate constant? Go back to my data. Well, it's right here. Right? Second order test. It's the slope of that line. So 0.0142. So 0.142. And this is in seconds. Inverse. Now, if I'm doing this for a grade, let's pretend I'm turning this in for class. So, I'm turning this in. All right, Dr. Bruck's report. You can put all of these on the same page if you would like. I have no problem with that. You could also print them individually. So there's my Excel data. Highlight. Now, if you click Shift, you can select all three of them at the same time. Whoops. Shift, click, Shift, click, and then click Copy. And now go back to my Word document. Paste. They're all right there. Now to make them smaller so that they fit on one page, you just grab it, make it smaller. Now don't make it so small that your scale gets all wacky. They're all on one page. Just delete that. Right, they're all on one page now. And I can go to my margins. So go to layout, margins, just make them real narrow. Everybody fits now. I can scale it. So long as I can see your scale and I can see, you know, that you've got your R² values there and I can read everything nice and neat, I'm happy. So you could print it out just like that. You could also print a full page graph if that makes you happy too. But this is enough for me for our lab report purposes. So if you have any questions about this, please feel free to email or come see me during office hours. And I hope that this helps you understand the relationship between concentration and time for zero order, first order, and second order tests using the integrated rate laws. And that's where we'll stop.